Check, 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 check.
Check, 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 check. Yes. Oh, morning, morning, everyone. Harish, Harsh, Don,
Yes, sir. Good morning.
good morning. Mohit, Devin. Yeah. So suddenly it has become a little colder here. In the morning it was sunny. So I think if not all of you, some of you are joining from the campus itself. So from 15th, from next week, we will have off-campus classroom lectures. So it will be a different experience for everyone. The same people you interacted with online, now you will be interacting with offline, that is together. So yeah, so it will be a different experience after COVID. For me also, this will be a new kind of experience. Yeah, as COVID started, things became online. Then they never became offline again. Now it will happen. Will be different. Yes. So coming back to what we were discussing. Just a second. Yeah. So I recently found out that Microsoft Whiteboard has updated. Yeah, it has become better, actually become more robust. So we can maneuver any way we like. We can do things. uh, we can do things like this. Earlier, it was very uh, sensitive, too sensitive, in fact. Now we can do it like this. We can uh, increase, zoom in, zoom out rather easily. Earlier, it was only one zoom, I think, either very big or two zooms, very big, normal, and very small. Now uh, we can zoom in as we want. Yeah, so we were discussing these things about regression. So we discussed what is meant by what is regression, and regression, what we are trying to do. We are trying to fit a line to the data points. So there are two variables, at least two variables, and we plot them and we try to fit a line to that data points, line of best fit. And we discussed what is meant by best fit, and we discussed how to find out the equation of line of best fit, that is the regression line, by finding out the slope and y-intercept. Slope and y-intercept. Many times we have discussed what is slope, what is y-intercept. Yesterday, I also mentioned slope is also called gradient. Gradient in some books. Gradient or gradient, the way you pronounce. Gradient, I think, sounds more familiar. So gradient or slope. Okay. So we did all this. We actually found out the regression equation for our example. For our example, this X is the temperature and Y was the sales figure. Sale of food item, that is pakoda, we discussed. So ultimately, we calculated the correlation coefficient, and using the correlation coefficient, we calculated the slope like this. First, we calculated the correlation coefficient. Okay. Then using the correlation coefficient, we calculated the slope. That is very easy. Correlation coefficient multiplied by standard deviation of y, that is the dependent variable, divided by the standard deviation of x, that is the independent variable. Yeah. So what we keep on the right side of the equation usually is called as the independent variable, and based on that we are trying to predict, we are trying to define the other variable that we call as y variable, which is on the left hand side. So usually it is like that. Any way it is given, you should be able to recognize. Yeah. So the values for which variable we are putting in values. We are putting in values and getting values of the different variable. So here we can put in different values of x, and we will be getting corresponding values of y. So x is the independent variable that we are choosing independently, and then correspondingly we are getting the values of y. That makes y a dependent variable. Yeah, in our situation, in the way we are defining. So it matters a lot in statistics how we are defining things, how we are defining the situation. Yeah. Many times you won't find as much predictability or robustness, or in other words, lack of possibilities, as you find in mathematics. Mathematics will give you most probably, most of the times, one single correct answer. In statistics, it depends on how you define the situation. So we have this equation ultimately y equal to minus 122.70x plus 4591.6, and then yeah, for 29 degrees Celsius, if on any day the temperature is 29 degrees Celsius, that is our x. Our x variable is 29. We found that sale of pakoda, that is our y variable, will be 1033.33. Then I also asked, if the temperature is 0 degrees Celsius, what will be the sale of pakoda? Did you think about it yesterday evening? Did you think about it? Given this situation, given this equation, regression equation or equation to regression line, if the temperature is 0, what will be the sale of pakoda? Then we will move on to discuss the third important point. The third important point, that is finding out how good is the regression line in this situation. In this situation, how well the regression line is representative of the data points, actual data points. That we will find out. First, please try to answer this. If the temperature is 0 degrees Celsius, what will be the sale of pakoda on that day? Yes. Shall I close my video? I think it improves the quality of other things. So I've closed my video. Yes. Anybody? Check. Yeah, I am audible, I hope. Yes, I am audible. Otherwise, one of you would have mentioned something on chat. Yes. So it is very surprising for me. How are you not trying to answer? It could be wrong or right, it doesn't matter, but why are you not trying? We have worked this far, step by step we have gone and calculated, derived the regression equation even. So after that, it's a small question. If temperature is 0 degrees Celsius, what will be the sale of pakoda? It's also not a tricky question. Please don't think I'm hiding some fact as of now. It's a very simple question. Okay, somebody has written something. Yeah, the question is, what will be the sale of pakoda? Given this regression equation between sale of pakoda and temperature, if the temperature is 0 degrees Celsius, what will be the sale of pakodas on that day? That is the question. This question, you want me to change the color? Yeah. This last line is the question. Yes. Anybody? Some response. No idea. Why no idea? uh, so all of you, most of you, at least the 7 of you, 6 of you, I think 6 plus 1 was me. So there were 7 yesterday. So we revised everything. Yeah, till calculation of regression line, derivation of regression line. So we have the regression line now. Now you can just put in any value of x. You want to find out what will be the sale if temperature is 10 degrees Celsius. So in this equation, you put x equal to 10. You want to find out what will be the sale of pakoda when temperature is 20 degrees Celsius. You put this x. This x. Okay, red x somehow gives the feeling of being wrong or something. Yeah. So in place of x, you can put in the temperature value. It will give you the sale of pakoda value, predicted sale of pakoda value. Yeah, the prediction is never perfect, but still it is better, much better than saying कि कुछ भी हो सकता है, anything can happen. Yeah. Yes, 4591. Very good. That is correct. So you put x equal to 0 here. This whole term becomes 0. Then the only thing remaining is 4591.63. Yeah. So that is the predicted sale of pakodas on a day where the temperature is 0 degrees Celsius. Okay. Yes. So now we can move forward to finding out how good is the regression line. How good is the regression line? So first we will see some concepts, then we will come back to the actual calculation. Okay. So now again drawing the data points. Just to explain the concept. Now suppose these are the data points. This is x-axis. That is the independent variable. This is y-axis. That is the independent variable. Yeah. Now, what we did earlier was find out a regression line. That is the line of best fit. Okay. Line of best fit. This is the regression. But after improvement, yeah, the choices in colors of pen has decreased, it seems. So this is the regression line. Oh no. It is as if somebody is listening and answering the question. Okay. Let's see.
Good morning, sir. नोट्स में लेना सारे पढ़ना कहाँ काम किया तुमने
Yeah. So this is the regression line. Now we want to find out how good is this regression line for this situation. So this regression line, of course, is a line of best fit. There cannot be any other line which will fit this data points better than this line. But in this situation, how good is a regression line? How good is the regression line? Yeah. So for that, what we do is one option which we have is compare it with the mean. One very crude way of predicting the output, predicting the dependent variable, that is y-axis, or in our case the sale of pakoda, is say everything will be the mean of the data we have. So the mean of data was 1800. So one option is saying that everything, no matter what the temperature is, everything will be the mean. Pay attention very carefully. This is a very important concept, and it will be there till whichever higher education you have got. This R square will be there. So one option is we can say everything will be the mean of this variable. Everything will be 1800. But by calculating the regression line, we are improving upon that prediction. Rather than saying that everything will be the mean, which is 1800, we are improving upon the prediction, our prediction. Okay. We can use the regression line, like the regression line we had here. We can use the regression line and come up with better predictions than just the mean, than saying everything will be the mean. Yeah. So comparing with the mean, now we will be let me take this actual point. Yeah, so we had a couple of points, this point, this point, this third point, this fourth point, this fifth point. Or yeah, to make it clear, just to make it clearer, I can take a point outside this. Or this is also okay. Let me just to make it clear. Suppose there is a data point here. Now you can after explaining, after hearing this explanation, you can try it out on any of the points, any of the other points. Okay. So suppose here is an actual point. We had predicted for this value of x, or this. For this value of x, our prediction was this, what is there on the regression line. But the actual value was this. Actual value was the upper circled one. Okay, that is clear. Yeah. So rather than just saying every value will be mean, we are saying the value would be this one, the cross one. Say the cross one is 1800. Yeah, say 1900 is the cross one, and the actual data was say 2100. Yeah, it is a little higher, so I'm taking 2100. Yeah. So our prediction was 1900, the actual data was 2100, and the mean is 1800. Okay. So now this part from the mean to our predicted value. Yeah. Our predicted value, which is denoted by y hat. Yeah. Y hat, or you can also add a subscript yi hat, because this is for this particular point, this particular circled point. Yeah. So when you take another point, the I will change. Okay. So for this particular point, circled point, our prediction was 1900, which is y hat. I'm just writing for clarity, because there should not be too many notation. बहुत ज़्यादा notation और numbers को बिल्कुल अगर हटा दें तो it leads to confusion, I have seen. And y bar. What is y bar? That is the mean. That is 1800. Okay. Now this difference is called residual. There is some lag in writing. Yeah. Residual. This difference is residual. In the diagram, it is this distance.
तो तुम वो एक टॉपिक बनाओ और उसके ऊपर उसका फिर कंपेयर करेंगे, फिर बताएंगे इस कंपनी का इतना था इतना। तो मेरे को कितने कंपेयर करेंगे? तुमने 20 का किया है?
This distance is residual, and this distance is called the error. It is not actually an error. We have tried our best with the regression line to make a prediction, but this difference as a nomenclature is called the error. Okay. Yeah. It is a common misconception that as we use the term error, people think we have done some mistake in our process. It is not like that. Yeah. So this distance is named as error. Okay. So comparing these two, now these two differences, what do they mean? This lower distance, this residual is defined as the difference which is explained by the regression line. Ideally, everything should have been mean. Yeah. But we have a different value than mean. We are predicting a different value than mean. That is, we are predicting 1900. So this difference between 1800 and 1900, this is the residual. This is the residual, and this is the explained part. Yeah. The other part is unexplained. The regression line we define is not able to explain this error difference. Yeah. But it is able to explain this much distance, this much difference from the mean to the value predicted by the regression line. Okay. Now, this actual value, which we denote by yi, without any anything above it, yi, that is the actual value. Okay. So actual value here it is 2100, and our predicted value again y hat. Okay. So this distance is, as we discussed, this is called the error. Now we are dealing with these two values. One is called residual, one is called error. Now, if we calculate all the residuals for all these data points, this data point, these actual data points, yes. So for all these data points, if we calculate the residual, and each of the residual, if we square it, and sum it. Square of the residuals
objective of this trial. This conduct this study.
or shall I maintain the color? I can write it in black then. Because here residuals I have written in black.
Excuse me.
Sir, I'm in a class, I'll discuss.
Just 1 minute. Just mute for 1 minute.
So please give me some time and come.
Just don't please add my name in that because I'm not available on Saturday. I told Karna. Okay, please don't add my name there.
Okay. Sorry about that. Okay. So this residual.
और वैसे भी क्वेश्चन को बनाना पड़ेगा क्योंकि हमको भी क्वेश्चन एरर्स निकालना है बोर्ड फाइल में बना के बोर्ड फाइल में पूरा क्वेश्चन बना के
Square of residuals. These differences for each value, each actual value, we calculate these residuals. Yeah. The difference between the predicted value for this point, it will be this. This whole distance will be the residual value for this particular point. So similarly, for each point, we can find out the residuals. So if we square out those residuals and sum of those squares, okay, that is called residual sum of squares. Now, similarly, we will do, as you might have guessed, we will do the same thing with this error, these errors. So, for each actual data point, we will calculate, of course, first the error, then square of those errors. Then sum of those squares. So that is called error sum of squares. Okay. So these terms graphically, visually also you understood. What is error sum of squares? What is residual sum of squares? Have you understood that? Everybody? We will go further. It is not complete. It is not finished. We will go further. Yes. Everybody understood till this? What is residual? What is error? What is residual sum of squares? What is error sum of squares? Have you understood? Not completely. Okay. Yeah, you can try to draw it by yourself. So there are actually three things, 3 points. For each actual point, we are getting 3 points. We have 3 points. One is definitely the actual point, yeah, which is the circled one. Then 1 point we are predicting by the regression equation. We are saying it should have been this. by the regression equation we have calculated, we are predicting that point. And the other third point is the mean. Yeah. So the mean is y bar. The predicted point is y hat. ये जो y के ऊपर arrow बना हुआ है ये वाला. So that is called hat. Y hat. टोपी जैसा है ना, hat जैसा. So y hat. And the other, the first point is the actual value that we denote by yi. Okay. Now we are taking two distances. One is from the predicted value, that is the point on our regression line, and the mean, we are calling it residual. And we are saying this is the explained variation. Explained variation. Yeah. Our regression line is able to explain this much variation. Mean नहीं है. Mean के जगह इतना value है, जो कि regression line वाला point है. That we say that this variation is explained. The regression line is able to explain that. But the actual value is still different. It is not the mean. It is not the predicted value predicted by the regression line. The actual value is still different. Yeah. So the difference between the actual value and the value predicted by the regression line is called the error. Okay. So this difference is called the error, and the difference between the value predicted by the regression line and the mean is called, okay, I'll switch off the video. Yeah. Yeah. So now the audio quality might be better. Yeah. So the difference between the value predicted by the regression line, this cross one, black cross one, and the mean, this difference is called the residual. So we have done this for one point. We can do this for all the actual data points available. Yeah. For all the actual data points available. Then we calculate two things. One is called the residual sum of squares. One is called the error sum of squares. What is residual sum of squares? These residuals, the difference between predicted value, that is point on the regression line, and the mean, the difference is called residual. For each point, each actual point, if we calculate those differences and square them, and then we are adding them. This summation sign shows we are adding those squares. Okay. So that output, what we get, is called residual sum of squares. So that means it will be all summation of, again I'll take out. There is some lag. Sorry. Yeah, okay. I think I'm using the Institute network today. It's supposed to be better. It is better, I think, compared to yesterday's Geo network. It is definitely better. Yeah. So sum of squares. So sum of residual sum of squares. That means all the y hat, difference between all the y hat okay, it is coming. Yeah, difference between all the y hat and y bar. Of course, y bar will be same for all the cases here in this situation. All right, I think I'll have to switch to the Geo network only. अच्छा हाँ, इतना dark हो गया, इतने बाद effect है. Okay, yeah. So this, all the residuals, we will sum them. Yeah, that we will call as residual sum of squares. And here, it's, yeah. I hope we are still connected and everything is fine. Okay, yeah, it seems lighter. Yes. Okay, I don't think I should be using that network again. S- Maybe it could out of overload or virus or something. So, this errors. What are these errors? How are we denoting these errors? Yi, that is the actual value, minus the predicted values for each data point. Then we are summing. So this is the residual sum of squares, and this lower one is called the error sum of squares. Now, logically, if we add these two, what we get, the term we get, we call it why this? Okay, okay, that is for arrow, I think. Okay, they have put in this new thing. So colors will be from here. Now, if I want to choose green, it will be here. So if we add the two sum of squares, what we get is the total sum of squares. Equal to the residual sum of squares plus the error sum of squares. So residual sum of square is written as R, error sum of square is written as SSE. So total sum of square is written as SSP. So let us write it like that. T total sum of squares. Yeah, let us follow this. SSP. SST equal to SR plus error sum of square, that is S. Okay. Now the ratio we calculate, which we called as R square, is this one. Which, yeah, that is. So R square is equal to the residual sum of square, that is the difference between actual value and predicted value. Oh, sorry, residual is the difference between predicted value and the mean, that explained part divided by the total sum of squares. This is a measure of how good our regression line is. Yeah. So roughly speaking, the numerator is telling us about the explained variation. That is how much our regression line is able to explain explained variation. Yeah. And the denominator is giving us the total variation. That is explained plus unexplained. So if SSR is the entire variation, if all the variation is explained by the regression line, definitely we will say that the regression line is very good. In this situation, the regression line is actually a representation of the data. Yeah, the data set. So if the entire variation is the residual variation. Yeah. So in that case, as we will see probably later, all the points will be on the regression line. Yeah. So there is, so it will be a case like this. All the actual points will be on the regression line. It will almost never happen. Yeah. So then, and the mean will be, of course, somewhere here. So this difference will be SSR, will be the residual rate. Now, what is the error? What is the error? Error is the difference between actual point and the predicted point. Now here in this case, actual point coincides with the predicted point. Predicted point is the points on the regression line. So that error will be 0. So that error will be 0. So the entire variation we say is explained by the regression line. In that case, as you can see, the numerator will consist of all the residuals only, and in the denominator, which is effectively residual sum of square plus error sum of squares. So all the errors are 0 because all the points are on the regression line. All the errors are 0. So total sum of squares will also be effectively only residual sum of squares. Total sum of squares is equal to, like I have written here, total sum of squares equal to residual sum of squares plus error sum of squares. In a situation where all the error sum of squares are 0, total sum of squares is equal to residual sum of squares. That is the numerator. So numerator and denominator becomes equal, and R square in this perfect case where all the actual data points lie on the regression line itself. In this perfect case, or in this, I would say, imaginary case, because in reality it never happens like this. In that case, R square will be 1. Yeah. As you might have guessed, So the value of r square will fluctuate between 0 to 1. Because we are taking a ratio, the denominator consists of something plus the numerator. Yeah, so it will always be less than 1. And it is a square value. So all the values we are squaring before adding. So it will never be negative. So less than 1 and never negative. So that gives us the possibility that r square value will be between 0 to 1. And as close to 1 it is, we say that the regression line is a better representation of our data points. Okay, so I think I have some graphs of different regression line, different r square values. So if I am able to do that, if I'm able to project that, it will get a clearer picture. So regression, yes, r square. Now look at these r square values. The left one, the upper left one is r square equal to 1 for a case where r square equal to 1. You can see that all the points are on the regression line. R square, if it is high, but the points are fortunately or unfortunately, we have found a regression line where the points are very near to the regression line. So then the r square is on the higher side, not 1, but still on the higher side. But if the points are more distributed, more away from the regression line, r square is, I would say, at mediocre level, yeah, 0.5. And if the points are very far from the regression line, still in this case also, the bottom right corner where r square is very less, still this line is the best fit. There is no other line which fits the data, no other line which fits the data better than this line. But r square is less. Yeah. Even if this is the best fit, the line of best fit, that is our regression line, r square in this situation is less. What is meant by that is, regression line is not a good representation of these data points. And perhaps we should not use regression if the data is like this. If after calculating regression line, if we see that r square is very small, there is definitely no point in using regression for the analysis, that particular analysis. Right? It makes logical sense, I suppose, to everybody. So it is not like once we have started with regression, we should force regression on the setting, on the situation. Yeah, we need to check if r square is giving us some confidence that this situation, in this situation, actually a line can represent our data points. In that case, we will say that we can go ahead with regression. We can use regression to predict values. Otherwise, we will use some other method. Yeah, maybe even non-linear regression. Maybe a curve fits some data better. Yeah. Or a different regular shape other than line fits the data better. So we can now we have all. I mean, not now, since couple of decades only, we have all those options. Not only we can fit a line, we can fit many other regular shapes to the data, yeah, and predict. The idea is to predict the value of dependent variable for non-dependent variables which we do not have. Some of the dependent variable values we will have. Based on that, we calculate this regression line. Then we try to predict for the dependent variable values which we do not have. Like in that case, we did not have 18 degrees Celsius in our data. we did not have 29 degrees Celsius in our data. Still, as we had calculated the regression line, we could predict the values of dependent variables for even those values. 18 degrees Celsius में क्या sales होगा, 29 degrees Celsius में क्या sales होगा of the pakoras, that we could predict. So this okay, yes. So effectively, so by this effectively we have seen the unit. Few more problems if you solve. You might have also realized that few more problems if you solve, it will help. Yeah, I'll also provide a link. Yeah, most probably the types of links we had for midterm practice. So I'll find which one is good for regression practice and pass on to you. So yeah. So now the only thing remaining technically are two correlation coefficients. Yeah, Pearson's correlation coefficient we have seen. There are two other correlation coefficient which deals with ranking when data is given in ranks, rank 1, rank 2, rank 3, rather than the actual value of the variable. In that case also we can calculate correlation coefficients. So those two correlation coefficients are remaining. Other than that, technically we have discussed all the topics in your syllabus, or let us say one round of discussion have happened with all of you. So now when you come to campus, we will start with revision and practice, a lot of revision. And as I have been repeating, as I have been repeatedly saying, I won't be simply repeating everything what we have discussed. Okay. So first, we will try to see till what most of you have understood, or till the minimum all of you have understood. We will start from there. Yeah, maybe the definition of regression all of you have understood. Maybe calculation of that slope some of you have not understood. So we will try to revise that. Yeah, similarly for other topics, maybe in means most of you have understood arithmetic mean. Geometric mean some people have doubts in. So we will discuss geometric mean, the definition of geometric mean, how to calculate that, when to use that. So we will go like that. Yeah, it won't be complete repetition of everything, but we will try to fill the gaps. जहाँ पे भी समझने में कोई गैप रह गया है, वहाँ पे हम fill करेंगे, वहाँ पे थोड़ा ज़्यादा practice करेंगे. So that way we will, yeah, we'll build a solid base for you further semesters. And yeah, and further life also, if you want to say like that. Yeah. All right. So I think, yeah, so we are about to end 3 minutes beforehand. Probably it has never happened before that we finished early, but yeah, we have discussed what we had planned to discuss. Now, if you have any doubts or suggestions, please share. So all of you will be attending sessions of sessions, will come to classes. Yes. From next week, all of you are prepared. All of you have arrived on the campus, most probably. Okay, I hope. Yeah, some network issues are there. There have been network issues all along. There's something not that much within our control. We can do few things. कभी रिसीवर को यहाँ रखने के बजाय और कहीं रख दिया, open air में रख दिया. So that much we can do and that we do. And of course, fortunately, in the office and the institute, we have IT person also. There is a major issue, we can talk to them. You can also talk to them when you are here. They are very good people. Not free people always, but good people, competent people. All right, then you proceed for your next session, next lecture, probably after lunch. Then we will meet again next week. Right. Have a nice weekend.